Hello, ladies and gentlemen. Okay, this is question 22 solution. That's 2014 question 35. Okay, well, if you look at this very well, this is under indices. Okay, so we're taking it one step at a time. Okay, and we'll try and touch base with all those questions because some people have been asking that okay, they want solutions and things like that. So before we touch the last part of maybe tomorrow or next tomorrow, last part in underlog readings, we can touch few questions that we can touch on the other parts too. Okay, but in this case now, we have this question that comes out from the objective part, and then we are asked to simplify. And this is simple and then straightforward. So if you've not gone through um questions under sort, under indices, under factorization, please other parts under that part, please go through them so that you can understand exactly what we are doing here. So if you look at this very well, we are told to simplify this. So the first thing you need to ask yourself that how do I break it down? So if you look at this very well, that's you have square root of 8 raised to power 2, 4n plus 1 raised to power n plus 1, 2 raised to power n times what? Times 16. So if you look at this very well, something is common here. Something is common here. Okay. So I can say 8 raised to power 2 is what? 64. Okay. This 64. 8 times 8 is what? 64. I can split this square to numerator and denominator to make it a bit faster for me. Okay. So, and if I look at it very well, I can say square root of what? 8 square times what? I'm splitting into numerator and denominator. 4n plus 1. That's square root of what? 2n times what? 16. I'm splitting it, okay, which is the same thing. That's in sub and in indices. It's the same thing. So if you look at it very well, so it means from here, I can now say that I can split it between both of them. Multiplication law under indices, I can split it so that you can understand exactly what I'm talking about. So I can have root 8 raised to power 2 times root 4n plus 1, okay, over that's root 2 raised to power n times what? Root what? 16. It's as simple as that. So what am I trying to do here? I'm trying to what? Simplify. I'm trying to break it down. I'm trying to break it down to what I cannot move further to again. Okay. So before I look at my option, so if you look at this one very well, 8 times 8 is 64. The square root of what? This will still give me 8. Okay. 8 times 8, 8 square. 8 times 8 is 64. The square root of 64 will still give me what? Will give me 8. It's as simple as that. Okay. This is the same thing as saying, I can say, this is the same thing as saying 4n plus 1, okay, times half. 4n plus 1 times half. Don't forget I said meaning of square root means what? Times what? Means root half. Okay? Means what? Half, power half. Meaning of square root is what? Power half. That's just the meaning. The same thing applies here. 2n times half. Meaning of square root means what? Power half. Please note that. What's the square root of 16? The square root of 16 is what? 4. 4 times 4, 16. It's as simple as that. So if you look at this one very well, I can say 4 here, 1, 4 here, what? 2. Straightforward. So 4 there, 1, 4 there, what? 2. So I can now say this, I can have 2 here times 4 raised to power n plus 1 all over 2. That's n plus 1 times 1 is what? N plus 1. Numerator times numerator. You know, this one is over 1, but we don't usually write it. So denominator times denominator. Okay. Okay, the same thing applies here. You can have 2 raised to power n, that's n over what? Over 2. 2 raised to power n over 2. It's as simple, it's as simple as that. So by the time we now do that, so the next thing we will do here is that, okay, if you look at it, we have 4 raised to power n plus 1 all over 2. We can raise that one to 2 raised to power 2, which is still the same thing. So this one is same thing as saying 2 times 2 raised to power 2, okay, all into n plus 1 over what? Over 2. Don't forget, it's still the same thing. 2 raised to power 2 is what? 4. Then you have your, then you have your 2 raised to power n over 2. It's as simple as that. So what do we do here? It means the power, the power here has numerator and denominator. So here you have 2 over 1, but 2 times 1 is 2. Then this numerator, multiply it. Don't make that mistake, because if you make that mistake, you might not be able to get the correct what? The correct answer. So please don't make that mistake. Okay. Ensure that, okay, you cover that numerator, that power of that numerator. That's n plus 1. That's n plus 1. So it means at the end of the day, you have 2 times 2 raised to power 2n plus 2. Okay. Over what? Over 2. 2 times n, we give you 2n. 2 times 1, we give you what? 2. So you have what? 2n over what? Over 2. So it's as simple as that. What am I trying to do? I'm trying to ensure that I work towards that 2, so that I can apply the law of what? Indices. I can apply the law of what? Of indices to ensure that I get my final answer. So I can apply the law of indices here in this case. So it means that here I can pick 1. I can pick here. I can pick 1, 2. Okay, all of them are in base 2. Okay, all of them are in what? Are in base 2. Okay, I can pick, so this is 2 raised to power 1, but we don't usually mention it. Multiplication change to what? Plus under what? Under indices. That's 2n plus 2 over what? Over 1. Then don't forget, under this part, division under indices change to what? Minus. That is, pick one base. This is 2 raised to power 1. The base is 2. 2 raised to power 2n plus 2 over 2. The base is 2. Then 2 raised to power n over 2. The base is what? Is 2. So for division change to what? Minus. So this one will be minus n over what? Over 2. So it's as simple as that. 2 raised to power 1 under the law of indices times change to positive, which is plus 2n plus 2 over what? Over 2 rather, not over 1, over 2. Okay. Then you also have, for division, this is long division, and they have the same base, pick one base. So division change to what? Minus. So what do you do here? You find what? LCM. What am I saying? I said you find LCM. So this is the same thing as saying you have your 2. Okay. So the LCM here, the LCM is what? Is 2. The LCM is 2. So 2 in 1 is what? 2. 2 times 2. This one is 1 over 1, but we don't usually write it. 2 in 1 is 2. 2 times 1 is what? 2. Okay. So then for the second one, you have 2 in 2 to be what? To be 1. 1 times 2n plus 2 is what? Plus 2n plus what? Plus 2. Okay. Then don't forget, for the last one, we have 2 into 1. 1 times what? N is what? Minus n. Don't forget the minus. Like I told you, anything on the right hand side is the owner of the what? Of the sign. The owner of this sign here is n over 2. Okay. And don't forget, is the division law that makes this one change to minus. We pick one base. For division law, it turns to what? To minus. It's very simple. So all you just need to do here is just that you have 2 here, you have 2 here. 2 has no n. 2 has no n, bring it together. The n1, 2n minus 1 will be what? 1n. So it means at the end of the day, the answer here will now be what? 2. Then you have your 2n minus n is what? N. Then 2 plus 2 will be what? 4. All over what? 2. That is the answer. So it means the answer is what? 2 raised to power n plus 4 all over what? All over 2. So the answer is what? 2 raised to power n plus 4 all over what? All over 2. So 2 raised to power n plus 4 all over what? All over 2. It's as simple as that. And it's just very, very straightforward. So the answer there is what? Let me rewrite it here so that it will be more clear. So the answer is there is what? 2 raised to power n plus 4 all over what? All over 2. So it's as simple as that. 2 plus 2, 4. 2n minus n, that is what? N. Okay, that is 2 minus 1, n. Then you have your denominator, which is what? Which is 2. So it's as simple as that. That's the answer is 2 raised to power n plus 4 all over 2. So that is the answer. All you just need to do, go to the option and pick your answer. So please continue to invite others so that others can also learn and see how these things are breaking down. Then continue to share, continue to comment, continue to like. Okay, and we can't be impacting you with knowledge, and at the end of the day you don't like it, you don't comment. Okay, so but please ensure you like, comment, and share, and invite your friends. Thank you. Cheers.